Hi, okay, so we're going to go over the homework for the test review. And the first one says, use these functions to answer each of the following. So we're using the functions f of x equals 2x minus 1 and g of x equals x plus 3. So the first thing we have is f of 4 plus g of 10. Remember what that tells us. In f, we're going to put, where there was an x, we're going to put a 4. So we have 2 times 4 minus 1. So that's the f. Plus, and if you want to kind of remember that, you can put like the f down here. And our g of x is 10 plus 3. And this is the g part, right? So when we put them together, we get 8 minus 1, which is 7, plus 10 plus 3, which is 10. So our answer would be 17. Okay, because we're adding those two after we evaluate them separately. We're adding the two together. So we get 7 plus 10 equals 17. Okay. Our second function is also an adding function. We're taking f of 0, so 2 times 0 minus 1, plus g of 0, which is 0 plus 3. And we're adding all that together. So we get 2 times 0 is negative 1, so that's minus 1. Plus 0 plus 3 is 3. So you put it together, you get a grand total of 2. Okay, so negative 1 plus 3 is 2. That's our final answer. Okay, so let's move on to the third one. Okay, f of g of 2. F of g of 2. So now we're doing a composite function. We have to do two things at the same time. This is telling us to do g first, and then what we get for an answer for g, we're going to put into f. So g of 2, remember we're putting 2 into the g machine, so that's 2 plus 3, which is 5. We put 2 into our g machine. Now we're going to take the output of that, which is 5, and we're going to input it into our second machine, which is 2x minus 1. So that's 2 times 5 minus 1, which is 10 minus 1, which is 9. So our final answer for f of g of 2 is 9. Okay. This set of directions is a little bit different. It's telling us to put 2 in f first and then work with that output for g. So f of 2, we're going to put 2 into machine f, which is 2 times 2 minus 1. And that gives us 4 minus 1, which is 3. Now we have to put that output into our second machine, which is g. So g of 3, and that's a 3 plus 3, which gives us a grand total of 6. And that's our answer. Once again, remember, guys, f of 2, we're putting 2 into machine f. So the 2 goes right there. 2 times 2 is 4, minus 1 is 3. Okay, we take that output and put it into the input of the next machine. 3 plus 3 is 6, our final answer. All right, let's look at the next couple of problems there. Okay, so this is telling us to do f of 3, so we're going to put f of negative 3 into our machine, and our machine is 2 times negative 3 minus 1. So that gives us negative 6 minus 1, which is negative 7. But it says 5 times that. So we have to take that negative 7 and we have to multiply that negative 7 times 5. Because we're taking 5, we're multiplying 5 machines, 5 f's, or 5 of the outputs, any way you want to look at it. So we end up getting negative 35. So negative 35 is our final answer there. Okay, our last, for question number 1, this is the last one. And once again, here we're told to multiply 5 times whatever the output of g is. So this time we're putting negative 3 into machine g, and that's negative 3 plus 3, so that gives us 0. And 5 times 0 is still 0. So our final answer for 5 times g of negative 3 is 0. That's the end of question number 1. So let's do questions 2 and 3. Provide an equation whose graph is parallel to the graph of y equals 2x plus 5 and passes through point 5, 6. So we have to do actually two things here. We know parallel, the slopes are the same. So let's see, the slope of this is right there because this is in slope-intercept form. So there's our slope, there's our y-intercept. We know parallel lines have the same slope, different intercepts. So we can write down y equals 2x, but we have to find that intercept. Now, in order to find that intercept, we have a point that we can work with. Remember, in that point, this is our x, this is our y. So we're going to put them into our equation. So our 6 goes there because that's our y. 2 times 5 is our x, and we're looking for our new intercept. So 6 equals 10 plus b. And how do we get b alone? We got to get this 10 over to the other side with the other constants. So we're going to subtract 10 from either side, from both sides. Okay? So 10 minus 10 is 0. We end up with b on this side. And on the other side, we have 6 minus 10, which is negative 4. Okay? So that's our y-intercept. So now we can write our equation. We know the slope's going to be the same. So y equals 2x, and we found our intercept is negative 4. So we get y equals 2x minus 4, and there's our final answer. Okay? So we did it. Now the next one's a little bit different. The next one says, provide an equation whose graph is perpendicular. Now perpendicular, we have to look at that slope, and remember perpendicular lines have slopes that are negative reciprocals of each other. So the negative reciprocal of 3/4 is negative, because this is positive. We give it the opposite side negative, and then the reciprocal, we turn the fraction on its head. So this becomes 4/3. So that's the slope of our new line. But we have a point. We have to find that y-intercept. So y equals negative 4/3 x plus our y-intercept. But we do have a point. We have a point at 6, negative 3. The negative 3 is our y. So we can put that in. Negative 3 equals negative 4/3 times 6. And we're looking for our b. All right. So 6 divided by 3. 6 divided by 3 gives us 2. And we end up getting negative 3 equals negative 4 times, we just simplified that fraction, so negative 4 times 2 is negative 8 plus b. So now we can solve for b. We add 8 to both sides. Why do we add 8 to both sides? Because we have a negative 8 by the b. We want to get that negative 8 away from b. So negative 8 and positive 8 is b. And negative 3 plus 8 is a positive 5. So we have our y-intercept. Our y-intercept is 5. Our slope is negative 4/3. Put an x there, equals y, and we're done. So if that's a little hard to read, I'll make it bigger over here for you. Our answer is y equals negative 4/3 x plus 5. Our new slope and our new y-intercept. Look at the slope. It was 3/4. We turned it upside down, gave it the opposite sign. That's what you're supposed to do with the slopes of perpendicular lines. And we gave it the intercept that was required to go through that point. Okay, so that's the end of question number 3. Okay, question number 4. We have a graph, and we're given a bunch of information we have to find off of that graph. The first thing is the slope. So we want to find a couple of good points. Well, obviously there's a good point right there. And let's look and see whether there's another good point that we can read easily. There's a good point right there. So let's see how we're traveling to get there from here to there. We go up first. Remember, it's up or down first. So we go up 1, 2, 3. So we're going up 3. And then we're going 1, 2, 3, 4, 5 to the right. So our slope is 3/5. Up 3 over 5. Up 3, right 5. Okay, our y-intercept. The y-intercept is the point of this graph that crosses the y-axis. That's the y-axis, and it's crossing it at negative 2. So our y-intercept is 0, negative 2. Why is it 0 first? Because the 0 is the x. We didn't move back and forth. We just moved up or down to get to that point. Okay, our x-intercept, x, we know we're solving for x. We want y to be 0. So this is where y is 0, and let's see where it's crossing. Ooh, it's It's not crossing at an easy to read point. So let's come back to that. We can find that in another way after we get our equation. Do we have enough information to get the equation? We have a slope. We have our y-intercept. Yes, we do. So let's write our equation. Y equals 3/5 x minus 2. So there is our equation. Now let's go back and find that x-intercept. It might be a little easier now. We know that at the x-intercept y is 0, so we could set this equal to 0. Do it right here. 0 equals 3/5 x minus 2, and we have to get that x by itself. So if we add 2 to both sides, we end up getting 3/5 x. Why are we adding 2 to both sides? To get this off of that side, right? Okay, we add 2 here, we have to add 2 on that side. Okay, now, in order to get rid of this coefficient here, if we multiply both sides by the reciprocal, which would be 5/3, we could do it in 2 steps, but it's a little faster and easier if we just do it in one. 3 times 5 over 5 times 3, well, that becomes 15 over 15, which is just 1. Okay, so we end up with 1x, which is what we want, equals, okay, on this side, 5 times 2 is 10, divided by 3, so 10 over 3. And that's good enough if we write 10 over 3. We could just leave it like that, that's fine. But if you want to simplify it, 10 divided by 3, well, 3 3's go into 10, so that would be 3 and 1 left over, so 3 1/3 would be where it should be. Let's see, well, we're at 3, and it looks like, yeah, it's about 3 1/3 is just about perfect. So there's our y-intercept. Okay, now we have to write an equation that is perpendicular equation. And we know in a perpendicular equation, what do we know? We know that the slope is a negative reciprocal. So we have a slope of 3/5. We want to, since that's positive, we're going to make it negative, and we're going to flip the slope. Then we're given an x, and this time we're not told a specific point to use, so we can put any intercept we want. So anything you want to write down on the back end is just fine. Okay, so there's a perpendicular equation whose the line would be perpendicular to our original equation. So y equals negative 5/3 x plus 9 plus 1,000,000 plus whatever you want on the back end. The only thing important here is that the slope is the negative reciprocal of the slope of our original line. So number 5, let's see, we're starting here. We want the slope. And let's see if we have another good point to read. Oh, we have a point there, we have a point there. Lots of good points to look at. So we go up 1, 2, and over 1, 2, 3. Up 1, 2, over 1, 2, 3. I would say our slope is 2/3. Our y-intercept is the point where the graph crosses the y-axis, right there. So that's 0, -4. Our x-intercept, oh, we can read it this time. Nice and easy. That's at 6, 0. That's the point where the graph crosses the x-axis. So our equation we can write is 2/3 x. Our slope, intercept, y-intercept is -4. So y equals 2/3 x minus 4. And a parallel equation, remember parallel means that we just have to have the same slope, different intercept. So 2/3 x, and as long as it's not minus 4 on the back, we're good. So we can plus 5, minus 100, whatever you want to put in there. As long as the slope is the same slope, different intercept, we're good to go. The last 2 questions you can pretty much write. I'm not going to write anything down. We're going to just discuss it because I want you to put it in semi your own words. There's a couple of words you have to include in your definitions. But in parallel lines, the most important part is that it's the same. There are 2 or more lines that have the same slope but have different intercepts. That's the basis of parallel lines. 2 or more lines with the same slope and different intercepts. Perpendicular lines are 2 or more lines whose slopes are negative reciprocals of one another. Okay, 2 lines whose slopes are negative reciprocals of one another. And remember, when we're talking about perpendicular, the y-intercept isn't important unless we're given a specific point that we have to find. So here the intercept isn't important. Here it's very important because the slope is the same, but the intercepts are different.